大家好, welcome. Raise your hand if you're excited for the first ever KubeCon and CloudNativeCon in China. Yay! So I'm Jenna Kuo. I'm a software engineer at Google. I'm co-chair of this conference, and I had a great time putting together the schedule with Liz Rice. We've got lots of great sessions scheduled for you. Today, I'm going to give you an overview of Kubernetes. And let's first take a look at how popular Kubernetes is today. This graph visualizes how many searches have been done globally since the beginning of this project. As you can see, the interest from Chinese users immediately stands out. And that's exactly why we have this conference here. Isn't that amazing? Combining the worldwide user searches results, you can see that Kubernetes is clearly trending and has grown exponentially. I started working on Kubernetes in mid-2015, and that's me. And shortly after I joined, Kubernetes 1.0 was released, and CNCF was formed. And it was all before the first ever KubeCon. During the early days, we focused a lot on moving fast and shipping new features because we want to get feedback as fast as possible. At the time, Kubernetes was so new and revolutionary that it's only adopted by a few risk-oriented innovators. And thanks to their feedback and contributions, Kubernetes has been improved a lot since then. Then we start focusing more on scalability so that you can run more workloads on Kubernetes. And we also focus on simplifying the user experience so it becomes very easy for you to set up a Kubernetes cluster. And we started getting more and more early adopters, and more enterprise users are using Kubernetes in production. We start hearing success stories from end users and how Kubernetes helped them improve their operating costs and allows them to deploy applications more efficiently. And because of Kubernetes' significant impact on how software is being written and how applications are built, this happened. Ta-da! Kubernetes won the 2018 Open Source Most Impact Award, and I felt so proud when I saw the news. And did you know that according to a recent CNCF survey, the majority of respondents are already running Kubernetes in production, and 40% of them are from enterprise companies. So it is very clear that Kubernetes has transitioned from early market of early adopters to mainstream market of early majority users. Those early majority users have very different expectations. They don't want to learn the complexity, the ins and outs of Kubernetes anymore. They want it to just work so that they can focus on what they actually care about, which is delivering their business values and react to market faster. And the good news is that Kubernetes is now so great, so solid, and so mature that it is now very, very boring. And don't get me wrong, boring is good. Boring means that a lot of people are already using it, and it just works. It's also good for mainstream market users because it allows them to run their business without worrying about operating Kubernetes. So when I was preparing for this keynote, I looked at the recent Kubernetes features, and I found that Kubernetes now focuses on two things. The first is open standard, and the second is extensibility. Now let's first take a look at open standard. Standards gives developers expectations around how a system the behavior of a system and how their applications will run. So Kubernetes provides a set of standard built-in APIs, and those APIs provides a convenient abstraction layer over infrastructure so that your applications are portable across different Kubernetes implementations. So because of that, you can run Kubernetes in all sorts of different environments. You can run it in hybrid, in multi-cloud, or even edge. And you can find sessions about running Kubernetes in different environments in this conference. The next standard is conformance. So Dan just mentioned the certificate. So when you see this certified Kubernetes logo, you can be sure that when you choose this service provider's version of Kubernetes implementation, you will get the required built-in APIs, and you will get consistent behavior. And that helps you to make your application truly portable across different environments. So to recap, with Kubernetes open standard, you can run Kubernetes anywhere, and you will get consistent behavior because of conformance. So we just talked about open standard. Now let's look at extensibility. So Kubernetes is extensible. It takes future growth into consideration when we design it. So extensibility has basically two parts. The first is infrastructure extensibility, and the second is API extensibility. Infrastructure extensibility means that with Kubernetes, you can customize how Kubernetes consumes the underlying infrastructure. For example, you can use different network plugins or storage plugins or even different container runtime. And you can also configure Kubernetes to leverage different cloud providers. Another extensibility is API extensibility. So I just briefly talked about the built-in APIs. They are generic, and they cover about 80% of use cases. But sometimes you need to customize for your own business needs, right? So with this, you are empowered to create your own custom APIs, and you can write your own controllers that automates the underlying text for you. What's more, you can create your own API policy so that you can modify your API objects and you can do some checks on them. Today, there are already more than 1,000 GitHub projects that leverage API extensibility. For example, you can use it for running machine learning workloads, for managing databases, for monitoring, for building serverless frameworks, or even for managing resources outside of Kubernetes. So it makes with Kubernetes, you can use a single config language to manage your in-house software and all open software. So to recap, Kubernetes open standard and extensibility makes it a ubiquitous general purpose platform for you to build your own platform. It has a set of standardized abstractions that allows you to make your applications portable, and you will get consistent behavior because of conformance. And Kubernetes is extensible, so you can customize Kubernetes however you want. And Kubernetes is open and compatible, so you are free to choose whichever solution that best suits your needs. Kubernetes is boring, and boring is necessary because you need it to be boring to be a mature platform with rich ecosystem for you to depend on and grow your business on top of it. Thank you. Our next speaker is Liz Rice. Liz Rice is a co-chair for KubeCon and CloudNativeCon and technical evangelist at Aqua Security. Today, she'll give you an overview of other CNCF projects. Please welcome Liz Rice.
Thank you, Janet, and hi, everyone. I'm so happy to be here at the very first KubeCon and CloudNativeCon here in China. So as Janet says, I'm going to be giving you an update on the major news that's been happening in the CNCF project since our last event in Copenhagen in May, just a few months ago this year. And a lot has happened. But before we dive into the individual projects, let's just recap on what we're trying to achieve with these projects we adopt into the CNCF. The goal is to create a full stack of the components that you need to run your applications cloud natively. As an end user, you should be able to build and run your applications in a fully scalable way with automated infrastructure and self-healing systems running in any cloud, whether it's public, private, or some combination. Now, that full stack of components isn't complete and comprehensive yet, and there will always be choices to make about how best to assemble the cloud-native stack that meets your needs. But the CNCF projects represent important building blocks that you can use. Let's use the CNCF trail map to walk through the different projects and highlight what's been happening over the last few months. So the first steps you'll take as an organization moving to cloud native is to decide to containerize your applications and dependencies and start building them automatically using a CI and maybe CD platform. And you'll be using an orchestrator. Janet has been telling you about what's happened in Kubernetes recently. You also need a way to define your applications so that they can run in Kubernetes. And that is the goal of the Helm project. Now, Helm used to be a sub-project under Kubernetes, but it recently moved to becoming an incubation project in its own right. And you can use Helm charts to define even the most complex of applications to run under Kubernetes. Having deployed an application, we need to be able to observe its behavior. And there are several projects under the CNCF in this observability category. Prometheus is a service monitoring system and time series database that's seen huge adoption in recent times. As Dan mentioned earlier, in August this year, it became the second project in the CNCF to graduate, and that's a really significant milestone. Leading up to graduation, the team focused on stability, and you can now reliably do more than 1 million data points per second on any modern machine and sustain that rate for years. The Prometheus team continue to expand, and they're working on documentation and making it easier to adopt Prometheus into your organization. Now let's move on to logging and FluentD, which is a lightweight solution for collecting logging data. Since Copenhagen, FluentBit released its version 1.0, and the original FluentD project is now at version 1.3 with native support for Amazon Kinesis and a new integration with Splunk. In the last 10 months, the Docker image for FluentD has been downloaded 35 million times, and FluentBit 13 million. Moving on to tracing, and the Open Tracing project defines a set of vendor-neutral APIs for tracing. And in recent months, they've released support for tracing Lua code, and they've delivered version 2.0 of Open Tracing for Python. Jaeger is an implementation of Open Tracing, and one really significant change since our last conference is that you can now deploy Jaeger using a new Kubernetes operator. Now, you'll be hearing a lot more about observability in Priyanka's keynote coming up later on this morning. Now let's move on to thinking about how the different application services can discover and communicate with each other. Envoy or Envoy, depending on how you pronounce it, is a high-performance service mesh proxy. And it's a very active project. There have been over 1,000 improvements from over 100 contributors since Copenhagen, with improvements to health checks, TLS support, load balancer flexibility, and lots more. In June, the Ambassador API project discussed why it had chosen Envoy over alternatives like Nginx or HA Proxy. And they actually highlighted CNCF ownership, as well as Envoy's focus on layer 7 capabilities. Services need to be able to discover each other, and Core DNS is a DNS server that can be used by Kubernetes as the cluster DNS service. And in fact, from version 1.11 of Kubernetes, if you're installing using kubeadm, Core DNS will now be the default. So congratulations to the Core DNS on achieving that. Linkerd is a full service mesh implementation, and version 2 was announced in September with a complete rewrite in Rust for the data plane and Go for the control plane. Linkerd can operate as a service sidecar that doesn't require cluster-wide installation. So as a service developer, you can access Linkerd features without needing access to the entire Kubernetes cluster. Linkerd now supports zero downtime configuration changes using a feature that allows multiple processes to bind to the same port. So you can start a new Linkerd process, wait for it to start handling traffic, and then terminate the old version. Moving on along the trail map, we'll skip past networking and the container network interface because they've remained pretty stable. So we'll move on to the question of storing data in a cloud-native application. Vitess is a database clustering system for horizontal scaling of MySQL. There's a session tomorrow discussing how JD.com have been using Kubernetes and Vitess for over a year with a massive system of over 4,000 shards. The Rook project moved out of the sandbox and became an incubating project in September. It's a file, block, and object storage solution for Kubernetes. They've also released a Rook framework to make a general-purpose solution into which storage providers can integrate their storage solutions. Moving on along the trail map, the CNCF also supports projects that enable cloud-native application components to communicate with each other. gRPC is a high-performance RPC framework based on HTTP2. They've recently released gRPC Web that allows web clients to communicate directly with back-end web services. gRPC now supports 16 different languages and has quick starts for 12 of them. The NATS project is a popular solution for messaging in cloud applications, distributed systems, and Internet of Things. Recent releases and ongoing work focuses on secure multi-tenancy and better algorithms for network topology optimizations. We're nearing the end of the trail map, and we will just pause to note that the Containerd project reached a significant milestone when Kubernetes announced GA support for Containerd as the runtime back in May. And our final stop along the trail map is the question of secure software distribution with the tough specification and the notary implementation of that spec. There have been recent announcements by Microsoft Azure and Datadog that they're now using tough. So that brings us to the end of the trail map, but there are other projects that the CNCF looks after in what's called the sandbox, because the projects in incubation and graduation are not yet a comprehensive solution for the entire stack that we're aiming to build. So the sandbox gives us the opportunity to support experimental projects. We've welcomed lots of projects into the sandbox, and there are two projects I want to mention, although the first, we just haven't moved it onto the trail map yet. We've already heard about Harbour, which was in the sandbox until 5 minutes ago. And I also wanted to mention TIKV, which is a distributed transactional key-value database, written in Rust, and also with its roots right here in China. The CNCF projects also have lots of recognition from the community, and I wanted to mention that InfoWorld run a series of awards for the best open source software, and our projects, 7 of those projects, won 8 of those awards. So can we have a round of applause for all those projects? So you're here at KubeCon and CloudNativeCon, and it's a great opportunity for you to learn more and get involved with these projects. Over the next 2 days, there will be plenty of sessions, which Janet and I had the pleasure of curating. And they'll teach you a lot about the individual projects, end-user stories, and all sorts of interesting things that are happening around the world of Cloud Native. There are introduction and deep dive sessions from many of the projects, and they're led by the maintainers and the leads of special interest groups and working groups. Those maintainers and project leads would love to meet you, help you learn more about their projects, and whether you're an end user or a developer, help you get involved or hear your ideas. And then finally, don't forget the hallway track. One of the main benefits of being physically here together is that we can have face-to-face discussions and get to meet each other personally. So I hope you have a fantastic time over the next couple of days. Hope you really enjoy your time here at KubeCon CloudNativeCon here in Shanghai. Thank you.